Hi, in this video, we are going to start looking at a method for getting the most simplified Boolean expressions. We've already looked at how we can take a truth table and get a Boolean expression out of it, right? But we are not very sure whether we've mm, got the most simple, the Boolean expression with the least terms that we can have. Right? You might have many redundant terms in your in your Boolean expression. So Karnaugh Maps is one way of simplifying and getting the most simplified Boolean expression. Okay, and that's what we're going to look at. So the truth table that I'm going to look at is given here. This is the truth table that we have been looking at before as well. Okay, and the what we want to do with in Karnaugh Maps is we want to convert this truth table into a slightly different form. Okay, and the form we are going to take is we're going to draw it as a square here. Okay, so let me draw a square here, and what we want to do is we want to place the min terms of the Karnaugh map at this spot. So you want to so each of these squares represents one combination of the inputs A and B. Okay, so one way of representing that would be to say this is A and this is values 0 and 1, and on the vertical axis you have B and they take the values 0 and 1. So then you can see that if I'm talking about this square, this is the square where A is 0 and B is 0, right? And what I can do is I can write the output at this particular place. So what is the output when A is equal to 0 and B equal to 0? You can clearly see from here that it's 1. So I can write that here. Okay. What is the value when A equal to 1 and B equal to 0? So when A equal to 1 and B equal to 0, you have again 1. So let's write that there. Okay. What do you get when you have B equal to 1 and A equal to 0? So that's 0, 1. So F is 0 there. So we can write 0 here. And similarly, you got 1 here. Okay. So once you do this, now what you want to do is you want to group the ones into as big a group as it is possible to do, right? But the groups can be of sizes which are the multiples of 2, right? It can be 2 or 4 in this case. If all of them are ones, so if this term was also 1, then you could have grouped all the 4s together, all the 1s together. But now this is not 1, so you can't group them. So you want to group the 1s together. So what we'll do is, let's group these 2 together. So that makes one group. As I said, the groups can only be powers of 2. So 2 to the power 2, which is 4, and so on and so forth. And then you can group these 2 together, right? So there are 2 groups of 1s, and there is no one. Okay, let's leave it at that. And now what we want to do is we want to represent each of these groups or each of these ones with a min term. Okay, now let's try to do that. So instead of writing the term for this one alone, what we'll do is we'll see, okay, is this one in a group with another one? The answer is yes. This one is in a group with this one, right? So let's represent both these ones with one single min term. And what is that going to be? Now, one way of thinking through this is, see, uh, in this group, A is taking both the values 0 and 1, right? If it is taking both the values 0 and 1, so it doesn't matter what A is. If B is equal to 0, then the output is always going to be 1, right? So the min term corresponding to that would be B bar. And similarly, if you look at this group of ones, you can see this is 1 and this is 0. So B, the value of B doesn't matter as long as A is 1, right? So the min term corresponding to that is going to be A. and you are going to OR the two minterms, and that is going to be your output F. And that is the most simplified version of the output that you can get. Okay, hope that makes sense. So what you're doing is you're combining the outputs where you have an output of 1 and combining those outputs into groups and writing minterms for the groups for each group together and covering all the ones in the K-map.